The fourth example, we're dealing with a more complicated case as compared to example 1 and example 2. Okay, it looks like a torsional element, but actually not. We're not using the torsional equations. Okay, so here we have a solid steel shaft with diameter of 33 millimeter, supports loads PA, PC, as shown in this figure. So bearings at B and D can be considered as pin supports. Okay, what does that mean, pin support? And the moment of inertia of the shaft is 58,214 millimeter to the fourth. Determine the magnitude of the maximum bending stress in the shaft. Okay, we're calculating the maximum bending stress. Okay, how to calculate that? We use MC over I. Right, C is already the maximum distance from the local centroid, from the centroid, and so here we need to find out the maximum bending moment. Okay, how to find it? Maximum bending moment. How to find it? We need M diagram. Okay, we need to draw the M diagram to find it out. Okay, so our first step to solve this thing will be to draw the moment diagram, right? So, but to draw the bending moment diagram, we need to solve the reactant forces, and then draw the shear diagram and then moment diagram, right? It's a step by step. Okay, we start from free body diagram. All right, let's simplify it into a two-dimensional case. Right, so we have PA here, PC here is already known, and we just add BY and DY here, since no loading is added along the X direction. Right, so we will get the first equilibrium equation, that is sum of Fy equals 0. Right, from this we can get By plus dy equals PA plus PC. PA is here, PC is here. It's 1400 plus 2100. That will be 3500 Newton. Okay, this one equation, two unknowns. Okay, so we cannot solve it. We need to get another thing, another equation based on the sum of moment about point B equals 0. Okay, you can also select point D, where you will get the same results. We just select B equals 0. Right, from this, we can get PA times L1 minus PC times L2 plus dy times L2 plus L3 equals 0. From here, over L2 plus L3, 200, 150, that will be 350. Right? From this, we can get 350 dy equals PC L2 PC L2 minus PA L1. Okay, so from this we can derive that dy equals 800 Newton. Okay, then from the first equation, we can get that By equals 3500 minus 800. That is 2700 Newton. Okay, then based on this result, based on PA by, PC, and dy. So we can draw the shear moment, the shear diagram. Right? We can draw the shear diagram that is from A. Here is A, have B, have C, and D. Right. So at point A, we have a PA downward. Right. PA downward, that is negative 1400. Then at point B, we have a BY that is upward 2700. Okay, so it will go upward by 2700. So this you will reach 1300. Right, then it will keep constant to point C. At point C, you have a downward PC. Right, downward PC is 2100. So you get a negative 800. Right, so this will be the same as dy. So negative 800. Okay, so this is the V diagram. Okay, then we can calculate A1, A2, and A3 so that we can draw our moment diagram. Right, so this A1 in this figure equals negative 1400 times L1, that is 100. Right, so you get negative 140,000 Newton millimeter. And A2 is positive 1300 times 200. That would be positive 260,000 Newton millimeter. Then A3 will be negative 800 times 150. It will be negative 120,000 Newton millimeter. Okay, based on these three areas, we can draw the moment diagram. Okay, have A, B, C, D. And we will start from 0, right? Since at point A, we don't have any bending moment. Start from 0, then it will encounter A1 that is negative. Right, so it will just decrease from 0 to negative 140,000. Then after point B, it encounter area 2, A2, that is 260,000. Right, it will go upward to point C. Right, so here will be just negative 140 plus 260, right? You get 120 here. Then it will encounter A3. Encounter A3 that is negative 120,000. So it will go down to 0. Okay, so this is our moment diagram. So from here, we can try to find where is our maximum bending moment, where you have the maximum bending moment, and what is the value. Here, right? So negative sign doesn't matter, right? So we only care about the magnitude values. So here we have determined that the maximum bending moment is negative 140,000 Newton millimeter. Okay, we also need to find out where is the centroid and the moment of inertia. Right, so the cross section is just a circle, right? It's just a shaft. So the C will be half D, 33/2, 16.5 millimeter, and the I will be pi over 64 D to the fourth. That will be 58,214 millimeter to the fourth. Okay, then in the end, we can calculate the maximum stress. That would be maximum moment times C over I. So it would be 39.7 MPa. Okay, again, this circle is just a symmetric cross section, symmetric shape. So the stress, the magnitude values of stress will be the same on top and on the bottom. Just on one side it's a positive, on another side is negative, right? So here, since we determined that this maximum bending moment is at point B, where it's a negative value, right? Meaning that at point B it will be bending in this way. So on top it will be in tension, on bottom it will be in compression. Okay, so you know on which side you have positive sign, on which side you have negative sign.